The invention of the microscope marked a revolutionary breakthrough in the world of science, enabling scientists to explore the intricate details of the microcosm and significantly advancing our understanding of biology and medicine. The journey towards the creation of the microscope began in the late 16th century when Dutch spectacle makers Hans and Zacharias Janssen experimented with combining multiple lenses in a tube, creating a rudimentary device capable of magnifying small objects. However, the true credit for the invention of the microscope is often attributed to Anton van Leeuwenhoek, a Dutch scientist and a contemporary of the Janssen brothers. In the 1670s, Leeuwenhoek crafted simple yet powerful microscopes using a single, high-quality lens that he ground himself. These early microscopes were basic in design, but allowed Leeuwenhoek to make groundbreaking observations. Leeuwenhoek's microscopes consisted of a small, spherical lens mounted between two metal plates with a screw mechanism for precise focusing. By adjusting the distance between the specimen and the lens, he achieved varying levels of magnification. Leeuwenhoek's microscopes were handheld, and the magnification achieved was remarkable for their time, reaching up to 300 times. With his meticulously crafted lenses and ingenious design, Leeuwenhoek became the first person to observe and document microorganisms. He examined a variety of samples, including water from ponds, saliva, and blood. Leeuwenhoek's discoveries included bacteria, sperm cells, and various microscopic organisms, opening up a new realm of understanding about the diversity of life at the microscopic level. The microscope's impact extended beyond Leeuwenhoek's pioneering work. Robert Hooke, an English scientist, used a compound microscope to examine thin slices of cork, discovering cells for the first time in 1665. This laid the foundation for the cell theory, a fundamental concept in biology stating that all living organisms are composed of cells. The design of microscopes continued to evolve over the centuries. In the 19th century, advancements such as achromatic lenses, which reduced chromatic aberration, and improved illumination techniques further enhanced the clarity and precision of microscopic observations. This led to the development of compound microscopes with multiple lenses for increased magnification and resolution. In the 20th century, the electron microscope emerged, enabling scientists to explore structures at an even finer scale. Electron microscopes use a beam of electrons instead of light, allowing for much higher magnification and resolution. This innovation revolutionized our understanding of subcellular structures and nanoscale phenomena. The invention of the microscope has had a profound impact on various scientific disciplines. In medicine, it has facilitated the diagnosis of diseases by enabling the observation of pathogens and cellular abnormalities. In biology, it has uncovered the intricacies of cellular structures and processes. In materials science, it has been instrumental in studying the properties of materials at the atomic and molecular levels. In conclusion, the invention of the microscope represents a pivotal moment in the history of science. From its humble beginnings with Leeuwenhoek's handheld devices to the sophisticated electron microscopes of today, the microscope has played a crucial role in unraveling the mysteries of the microscopic world, shaping our understanding of life and matter.